So this is lesson 3 about circles and pi. So here's a circle, and of course the circumference of this circle is 2 pi r, 2 times pi times r. We saw that in a previous lesson. So r is the radius from the center to the edge, and then 2 pi r is 2 times pi times the radius, and that gives you the circumference, the length all the way around the edge. 2 times pi times r. Pi, remember, is that number 3.14159 and so on. So because the whole circumference of the circle is 2 times pi times r, I've split it up into blue and red, and the red edge, so that's that plus that, adds up to just 1 times pi times r, or just pi times r in other words. And the same for the blue bit. So the blue bit adds up to pi times r, the red bit adds up to pi times r, and that gives you the whole circumference adding up to 2 times pi times r. So we're just talking there about length around the edge. Now I've split that up into 4 parts, red and blue, but I could equally have split it up into 8 parts, red and blue, and then the same thing would have been true. The red part would have added up to pi times r, the blue part would have added up to pi times r. Could have done exactly the same thing for 16 parts. Now I can rearrange those parts with all the blues with the curve up pointing downwards and all the reds with the curve down and the sharp bit pointing upwards, and it kind of resembles a rectangle. So you've got the pi times r along the edge, that was just the red length, or indeed the blue length along the top, and then the radius of the circle down the side, because it's the center of the circle to the edge. So you've got a kind of rectangle that's pi times r one way and r, the radius, the other way. And in fact, the more pieces you use, the more it will resemble a rectangle. And then eventually, with millions, billions, or infinite pieces, it will look exactly like a rectangle. And then that rectangle will be pi times r along the bottom and r down the edge. So the area of this rectangle would be pi times r, or in other words, pi times r squared, pi r squared. Now that rectangle is just the circle cut up and rearranged, so that means the area of a circle is pi times r squared, pi r squared. So that's how we get the famous formula for the area of a circle being pi r squared. So here's an example of putting that into practice. There's a circle, it's got a radius of 2 centimeters, so the area is pi r squared, pi times 2 times itself. So that gives you about 3.14 times 4, which is about 12.56. And indeed, if you count the squares, these squares are half centimeters, so you have indeed got about 12.5 squares, 12.56. You can see them there and count them, and then try and include all the half bits. About 12.5 squared, so it does check out. Example 2, what if we're given the diameter instead of the radius? Diameter 12 meters in this case. Well, that's easy enough. If you know the diameter, the radius is just half of it. So diameter equals 12, radius equals 6, and then just stick 6 into that formula. So the area is pi r squared, so that becomes 3.14 times 6 times 6, which comes to about 113 meters squared, bearing in mind that I've rounded pi, of course. So you can have a go at exercise 17C on page 349.